Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you how to compute permutation importance. So before we begin, let me quickly give you an introduction of what permutation importance is, and also take this link and put it here so that when you go back to this notebook later, you know where to get like the documentation for permutation importance. So first of all, what is permutation importance? So permutation importance is a way to compute future importances for any black box estimator by measuring how score decreases when a feature is not available. The method is also known as permutation importance or mean decrease accuracy. So basically, the algorithm works by measuring how the score, in this case R2, we're interested in, decreases when a feature is not available. So I am going to be running this permutation importance on a regression model. So we are going to be using R2 to score this. But basically, what is measured is like, so if we remove a single feature, how much does the score decrease? This will give us an idea of how important that feature is. And they do this by removing a feature from the dataset, retraining the estimator, and then checking the score. So it makes it clear here that removing a particular feature and then retraining the estimator with the dataset is really computational intensive. It's going to cost a lot of computational time, right? So they don't actually do that on the training data, they do it on the test data. But even if you do it on the test data, there are still some problems because your training, because you trained the estimator with your training data, let's say it has 5 features, and when it comes to your test data, if you remove one feature to compute how much the estimator is gonna go down, well, the estimator is expecting 5 features, and your test data, if it was going to have 4 features, if you remove a single feature to test the score of the estimator. So what they do right here is, instead of completely removing a single feature and then running the remaining data sets through the estimator to get the new score, what they do is they replace that feature with a noise and then run the estimate and then run the data set through the estimator. Okay, they replace the feature with a noise, and when they replace the future data with noise, this future no longer contains useful information. And since it no longer contains useful information, we can then run our data set through the estimator and kind of see how the score decreases if we replace this particular feature with random noise. So if you want to learn more about how permutation importance is computed, I suggest you come to this page and read more about it. But I just wanted to give you a quick brief overview of how permutation importance works. And of course, I'm going to put this link in the description below and also in the notebook. So quickly, let me go ahead and show you our training data. So before I started this video, I went ahead and did all the cleaning required and split my data into training and test data set. And just to give you a quick overview of what's happening, so basically let's take alcohol for example, right? What it's gonna do is it's going to drop alcohol column and then run all of this data set and then to see what the R2 score is. But if you do this process over and over again, it's gonna be computationally intensive, especially if you have a large data set. So what it's gonna do is, instead of dropping alcohol and running this over and over again, it's going to replace the data, the information in alcohol, with random noise and then run this through the estimator. But it's going to be doing this on the test data set. So it is going to train with the training data set, and then when it comes to the test data set, it will use it to do the permutation importance. And then also this is a problem I was talking about earlier. So if you have all these columns right here and you train with this, right, and then you drop alcohol from the test data set, while your estimator is expecting the alcohol column, and if you put the test data set through the estimator without the alcohol column, it's going to throw an error. So that is why we don't actually drop it, we just replace it with noise. And I hope that kind of makes sense. And again, to get more detailed information, just go here. So scikit-learn also has an implementation of permutation importance, but it's not as easy to use and intuitive as the one I'm about to show you. So the one I'm going to be showing you right now is from ELI5. So with this preview, let me go ahead and actually run this code that I have right here. So the first thing you want to do is make sure you install ELI5. Let's go ahead and run this. Oh, by the way, you can do something called capture magic, so it doesn't print all of this. All right, so now we are going to import ELI5 after installing it, and then we are gonna get permutation importance from ELI5. And I'm going to try to explain stuff as we go along, but after writing all this code, I will go back and explain it again. So if you feel lost as I'm writing this code, don't worry, I'll go back and re-explain it. So let's call it permutation. All right, and we are gonna put in our X train, Y train, S test, Y test. First, we are going to pre-process the data. So if you look here, we have status in our data frame, and status is a categorical variable, so we need to convert this categorical variable into integers. So that's kind of like the pre-processing that we need to do. If you need to standardize your data or impute missing values or anything like that, you can do all of that pre-processing right here. Make sure you do your pre-processing first. Encoder is equal to ce dot one hot encoder. Okay, now one hot encoder, let me show you the code to get this right here, to get this. So basically, before you can do this line of code, make sure you do pip install category encoders. Make sure you install category encoders first, and then you import category encoders as ce. I've already done this step earlier in the code, so that's why I didn't do it again. So, but if you're working on this project along at home, make sure you have category encoders installed. I'm using one hot encoder from category encoders, and I'm gonna be using the default everything except this one. I want this to be true, so I'm gonna call xtrain s. I don't know, let's call it s. Why not? It's equal to encoder dot fit transform. I want to fit transform my xtrain data, and then s test s is equal to encoder dot transform my s test. All right, now this is where we fit the model. So even if you are writing like a function like this for doing your permutation importance, make sure you do your pre-processing first, and then you fit your model. I'm going to be using a decision tree regressor model. Why decision tree? Because that's what I've been using all day. Or I can go ahead and do random forest regressor. So if I go back here and let's say from sklearn.ensemble, import random forest regressor. So let's just use the random forest model. Why not? You could use random forest or any model that you're working with. So model is equal to random forest, and I'm just gonna set the random state to 42, and basically I'm just using the default everything. And also random state, just make sure that when you run this code at home or when I run this code later, I'll get similar results to what I have now. So now let's do model.fit. Let's fit our model to X train S and to our Y train. So let's call it permuter is equal to permutation importance. And let's go ahead and fill in the parameters. So here you can see like the different parameters that it's kind of expecting from you. We have estimator, we have scoring, we have number of iterations, we have random state, CV, refit, and other stuff. So let's just go ahead. So I'm gonna say estimator is equal to model. So basically we are saying what are we going to be using as the estimator, as a model for this permutation importance, and we're just going to be using this random forest regressor model here. And then the next thing is asking us for scoring. How do we want to score this? And we want to use R2. So how would you know which scoring to use? So let's go to scikit-learn real quick. Let me show you something. So if you come here to scikit-learn, this is like the different scoring method. So for classification, these are the method you could potentially use. For regression, these are the method you could use. And in this case, I'm just using the R2 score. You could use any one of these if it interests you. I'm gonna go ahead and take this link, and I'm also gonna put it here. And then we are going to put the number of iterations, like how many times we want this to be done. We want to set this equal to 5. You can set it to 10 or whatever you want to set it to. And I'm just gonna set the random state equal to 42 just to get consistent results. So we have, in this situation, defined or instantiated our permutation importance module, and then we provided the parameters for the permutation importance. So now we do permuter.fit s test s, I believe that's what I call it, and y test. So just make sure you keep track of what's going on here. Like, well, I'll come back and go through this again. So just to make sure that you understand what's going on. So we are gonna do our future names. That's like basically our column names. We are gonna do s test s dot columns dot to list. So basically we are getting the columns from our data frame and we are putting it in a list. And then we are going to create a series, panda series between our future importances and our columns. All right. So future importance is going to be equal to permuter dot future importance, and it needs that at the end. So here in this situation, we are getting the column names, we are getting the future importances, and then in the next part, we are pairing up this future importance with our columns. So let's do pd.series, and then we want to create a series between our future importance and our columns, and then we want to sort them, and then ascending equal to false. So in this situation, what we are doing is we are creating a series between our future importance and our columns, and we are sorting the values, and we want ascending equal to false. Now let's go ahead and do, this is the part where we actually create the visualization. So dot show weight, and here we want so if you look at the documentation real quick, it wants what the estimator is, and then it has some other keywords. So in this case, I'm gonna do estimator is equal to permuter, and then we're gonna set the top equal to none, and then we are gonna say future names is equal to column. And I'm just gonna bring this back here for clarification, and then we are gonna do return metric. So I'm gonna go ahead and run this, and once I confirm that this works and we don't have any errors anywhere, I'll come back and explain this again. So let's go ahead and execute this, and then in the code cell below, let's go ahead and call our function. And our x train is our x train, y train, s test, y test. So I already created an s train, y train, s test, y test data frame earlier. So let's go ahead and run this. Okay, we have a small typo. This is future importance 6. Run this and run this again. All right, so it works. That's really exciting. Right, so this is our future importances. So we can kind of see what our future importances are, right? So before I kind of explain this and what it means, let me quickly go back here and explain the code. Here, we first pre-process our data to encode our categorical features using one hot encoder. And that's basically what we did right here. This is like the encoding process. So we train on a regular random forest model or any model that you want to choose. And then we fit the permutation importance on the test data, not the training data. Okay. So then here we just be able to visualize our data set, we went ahead and got the columns from our data frame, and then we got the future importances, so we can do this. So you don't actually need this in order to get this result. So if I go ahead and comment this out and run it and run this, you still get the exact same results. Okay, so this right here is just for another way for you to visualize what's going on. It will give you the same information, well, similar information. So if I go ahead and call this combo is equal to this, and then I also want to return, let's say here I want to return combo. Just want to show you how this works. And let's go ahead and run this. So what we have here is the raw data, without without showing you the difference and weight. So HIV/AIDS, schooling, and other stuff. So if you wanted just this raw data as it is, this is how to get it. You can get it in here, but this is not necessary for the permutation importance. This is just extra stuff. And this is just for us to be able to create the visualization that we had before. Let me go ahead and change this to metric before I forget. And basically, estimator is just the model that we're going to be using for visualization, and tab equal to none just means to show all features and not just the top ones. So actually, if I go ahead and change this to, let's say 5, then to show me the top 5 features. So 10 more. So basically, you can put this equal to none to show all the features and not just the top ones. But if you put, let's say 5 or 10 to show you the top 5, that's what this does. And then basically feature names is equal to the columns. So what are the names of the columns? And basically, what does this actually mean right here? So basically, this is like when we remove this HIV/AIDS feature, the R2 score decreased by 0.54, and this is like the variance from this score, so plus 0.07 minus 0.07. So this is kind of like plus or minus the, so 0.54 plus 0.07 slash 0.54 minus 0.07. So that's kind of like the, I don't know, do you call it the deviation? So basically here what it's saying is that when we remove the schooling feature, the R2 score decreased by this much. When we remove the BMI feature, the R2 score decreased by this much. When we remove the thinness feature, the R2 score decreased by this much. So this kind of give you an idea of which features are most important. And you wouldn't use a model like this, an explanation method like this in isolation. You will use it with other explanation method, but this is just one way to explain your models. And to learn more about weights, I went ahead and added an additional link here. Actually, I haven't added it. So this is the ELI5 show weight documentation. You can come here and look at it, and you can have a positive number and negative numbers, and kind of look at this. So under the show weights parameter, so here in the show weights parameter, right, I only have a few things, but if you come to show weights here, there's many other things that you can add to your show weights. And I'm gonna take this link and I'm gonna add it here. If you want to learn more about permutation importance, you can also check out the scikit-learn explanation of future importance. I found this very useful too. So I'm gonna go ahead and add this here. And to get access to this notebook that I use in today's video, you can go to machinelearningeducation.com, and once you are here, you can click on free data science resources. And here you get access to this notebook and many other notebooks. So I create a lot of YouTube videos, a lot of blog posts, and I end up with a lot of tutorial notebooks. And I just found it easier and more straightforward to just create one platform where I put all my data science notebooks, all my data science videos, all my data science blog posts, all my data science content under one platform. So you can go to machinelearningeducation.com/free to get access to this notebook and this code that I use in today's videos. And you can also find me online at evidencen.com. So this is my primary website where I have data science blogs. And as time goes by, I'm going to add more and more data science blogs. But evidencen.com, and once you are here, you can also click on this to get to free data science resources. And again, this is where I have the code for today's video, and I have all my other data science notebooks. That's machinelearningeducation.com/free. That's it for this video. If you have any question, let me know in the comment section below. And if there's anything particular you want me to tutor about, also let me know in the comment section below. Thank you for watching, and I'll talk to you on the next video. Bye.